Welcome to Automated Visual Software Analytics. This part is about software analytics. We will explore the need for software analytics and principles of software analytics, and we will also define automated visual software analytics. Let's start with the need for software analytics. In this quotation, this need is illustrated. In software engineering, there's much we are seeing, but little we are learning. The sheer volume of software engineering data is overwhelming. Yet from that data, we have extracted nearly zero general principles. That's a key message here, and it refers to software engineering as an engineering discipline. And of course, if you have nearly zero general principles, this raises the question, is this true engineering? The usual result across all this data is that what works on one project may not work on another. Hence, there's an urgent need for better analysis of this data. Further, due to the volume of information, that analysis must be at least partially automated. This quotation could be summarized as a reflection on the software crisis, an older term that was used to describe the principal problems in software engineering, especially as an engineering discipline. So let's see, why should we have software analytics? What are the general needs for large-scale, long-term software projects? To give you some examples, for example, generating defect predictors to guide inspection teams might be one need. The estimation of technical depths in software projects, so future costs that the software implies already. Predicting software power consumption, especially in the scope of app development, or predicting overall project effort. Finding effective project changes or revealing the human networks inside software teams, generating normal interface usage patterns based on execution traces, or recording application usage and context data, for example, for apps. This list contains just a few general needs that can be fulfilled with methods, techniques, and technologies from software analytics. Software analytics aims at providing means to answer this kind of questions. Let's see how visual software analytics or automated visual software analytics is positioned within the scientific fields that are involved. Software analytics, and more precisely automated visual software analytics, uses findings from analytics and visual analytics, so it's a specialized form of visual analytics. It's oriented towards the domain of software engineering, and it uses and applies methods from information visualization. In a sense, automated visual software analytics is a multidisciplinary approach, taking into account analytics and visual analytics as a foundation, together with specialized information visualization approaches, and all this is done for data that comes from software engineering projects and systems and solutions. In software analytics, we have to be aware that we are talking about very different stakeholders and very different needs of these stakeholders throughout the whole software development process. A typical group of stakeholders involves, of course, the developers, maybe also the researchers, the people that test software, the leaders of development, the leaders of the tests, and of course managers that are responsible for the success of a whole project and responsible for the budget. Can you imagine easily that these different groups of stakeholders have very different needs throughout a software development process that needs to be considered by software analytics. Automated visual software analytics refers to analytics as a general discipline, the underlying foundation. Automated visual software analytics is specialized to data and information relevant for large-scale, long-term software development projects. It uses and actively applies visual and interactive techniques to provide access to complex data, and to do so, it relies on automated data gathering, integration, and fusion, using different sources of information available in software development projects, such as repositories, source codes, bug reports, bug lists, and any other kind of information, for example, runtime traces or test information. Automated visual software analytics uses and requires visual interfaces, for example, to visualize the source code and the hierarchy of system components, to visualize source code metrics associated with source code units, to visualize the results of software tests or runtime traces, and to visualize the system evolution. The constraints to be observed and to be respected by automated visual software analytics include: there's no natural geometry or form or shape or gestalt for most of the data, so we have to find appropriate mappings to make this data actually visible to the human eye. We have also to find appropriate visual metaphors for visualizing software data, for example, in terms of a software landscape or a software map. And we have to find appropriate interaction techniques to handle the process of exploring software data. Automated visual software analytics relies, as already said, on the gathering of data, the automatic gathering of data, such as data from repositories, from measurements of certain software metrics, and the results of software tests and runtime traces. Here, the constraints include that we do not have any explicit models or meta-models that are added to our software development in order to do visual analytics. So this means visual analytics cannot rely on extra work, extra effort that would have to be spent. Instead, it must operate on the raw data that is already there in software development projects. We can also not expect that people adapt the software development process or use specialized new different tools for their daily work, for example, the integrated development environments. So we have also to keep in mind that visual software analytics cannot rely on any specialized changes to the software development environment. And we have to take care and to ensure that there is no interference with programming language usage or programming guidelines. Once again, here we cannot expect that people program in a different way or use a different programming guideline just in order to allow for visual software analytics. That means visual analytics has to be able to operate on the raw data that is already there in software development projects. This is a key restriction, of course. It would be easier if we could impose or assume certain ways of software development, modeling of software development processes, etc. But software development is much more complex in practice, and for visual software analytics, we cannot expect people to change their daily tool suite or the frameworks they are using already. Automated visual software analytics is faced by two key criteria. First, it must be automated. That means collecting and gathering the broad variety of data about software systems, their development, their dynamics and evolution must not depend on explicit or manual steps, for example, based on consultancy work or constructing, setting up, designing meta models. For large-scale, long-term projects, it is practically impossible to achieve better engineering by any normative approaches that impose certain behavior on involved developers or any other stakeholders in software engineering processes. The second criterion is it must rely on visual technologies that are able to master big software engineering data. That is, software analytics requires effective means in terms of interactive interfaces to the data. As software data is related to an extremely complex and intangible artifact, the implementation, the dynamics and the evolution of a software system, strong visual metaphors need to be applied and sometimes need to be imagined and designed that allow to get actionable insights into the data. These are the big two constraints or criteria that visual software analytics has to take into account. Let's summarize. Software analytics follows the principles of analytics, specialized to the demands and conditions common to large-scale, long-term software development projects. We have seen there's an enormous demand for software analytics. Engineering techniques in software engineering must grow and evolve to cope with the increasing role of complex computer-based systems in a more and more software-dependent society to ensure system dependability. Software analytics is most likely the key step towards a stronger engineering in software engineering, providing a rich framework that enables effective comprehension of complex computer-based systems, their evaluation and corresponding decision-making. Key criteria for software analytics include automation, a high degree of automation regarding data collection and data gathering, as well as data analytics, and effective visual interfaces based on adequate visualization, metaphors, and interactive techniques. Yeah, this concludes this part about software analytics. The key term introduced here is automated visual software analytics. Here we have a definition of this term. Automated visual software analytics denotes principles, concepts, methods, and techniques of visual analytics. It's a kind of recursive definition that take into account the specific demands and conditions in large-scale, long-term software development projects and software engineering in general, that automatically gather data from the broad and wide variety of data sources common to software development and software engineering, and finally, apply effective visual interfaces based on metaphors that allow for mapping the data of these intangible artifacts. As further reading, I recommend this article about predicting the future of predictive modeling. In this article, there's a lot of illustrations for the need for software analytics and the current state of the art in the field of software engineering. Finally, a short remark. Personally, I believe that automated visual software analytics will be the game changer in software development, a game changer that really impacts how people, how organizations, how companies will develop software systems, software-based systems in the future, and how to improve effectiveness of development processes. It will significantly contribute also to mature the software engineering discipline.